Hey everyone, and welcome. If you've ever looked at an AI agent and wondered, yeah, but how does it actually work under the hood? Then you are in exactly the right place. We are going to build one step by step, starting from scratch and ending up with a system that can really think. So, let's dive in. It really all boils down to this one big question. And I'm not talking about a simple chatbot that just spits back pre-programmed answers. I mean a system that can reason, that can use tools, that can even look at its own work and say, I can do better. So, how do we get there? Well, the answer isn't some abstract, high-level theory. It's right here, in the practical code. We're going to walk through a single project that starts out as a basic script and evolves, piece by piece, into a sophisticated agent. You're going to see exactly how each new capability gets bolted on. There's no magic here, just logic. All right, before we can start building anything cool, we need to lay a solid foundation. So first things first, we've got to get our project environment set up so that everything runs smoothly right from the get-go. Our setup is actually pretty simple. It's just 3 key steps. First, we'll install all the libraries we need. Then we'll configure our code to talk to a model running locally with Llama, which is great for speed and privacy. And finally, we'll run a quick health check to make sure the AI is actually awake and listening before we start asking it to do things. So, let's break down what we're pulling in here. Ollama is our bridge to the local LLM. The search and Wikipedia packages, those are like giving our agent its first set of eyes and ears on the world. But pay special attention to that LangGraph library. It might seem like just another package now, but trust me, it's the secret ingredient for the really powerful agent we're going to build at the very end. Here, we're just telling our script which model to use. In this case, Llama 3.2. Then we run this really simple but absolutely critical health check. Think of that assert line as our safety net. It just pings the local server to make sure it's alive and well. If it's not, the script fails immediately, which is exactly what we want. It saves us from a whole bunch of confusing errors down the line. An agent is really only as good as its tools, right? In this part, we're going to give our agent its first toolkit, so it can do a lot more than just string words together. We're starting with 3 essential tools. A calculator, because you never want an LLM doing math on its own. A web search for getting real-time info that the model wasn't trained on. And Wikipedia for doing those deep, factual dives. You can think of these as covering the agent's 3 basic needs: calculation, currency, and knowledge. Now, this is super important. Giving an AI a calculator sounds easy, but just using Python's eval function by itself is a massive security hole. So what's the solution? We create a secure sandbox. See that allowed dictionary? We're explicitly telling eval it can only use basic safe math functions and nothing else. This gives the agent the power it needs, but keeps our system totally locked down. Okay, our agent has its tools, that's great. But now let's make it smarter. We're moving on to the next big evolutionary step, teaching the agent how to think about its own answers and actually improve them. This right here is a real game changer. A standard LLM just gives you a one-and-done answer. But a self-checking agent, it works more like a person does. It writes a first draft, then it steps back and critiques its own work, and then it refines it into a final answer. It's like having a built-in quality control loop. And you know what's so cool about this? The way we implement it is just so elegant. It's not about writing complex code. It's all about clever prompt engineering. By forcing the model to respond in this very specific draft, critique, final format, we're basically tricking it into performing this entire reasoning process all in one go. It's a fantastic example of steering the AI's behavior just through the prompt itself. Okay, let's level up again and look at the next key pattern: ReAct. This is where the agent really starts to think out loud. The name says it all. It's about combining reasoning, where it forms a thought about what to do next, with acting, where it actually picks a tool and uses it. This thought-action-observation cycle is the secret sauce for tackling problems that have multiple steps. Instead of trying to guess the final answer right at the beginning, the agent just takes one small step, observes what happens, and then uses that result to decide its next move. It's a way more resilient approach for solving complex questions.
And this line of code, this little bit of regex, this is the engine that drives our simple React agent. All it's doing is scanning the model's text output, looking for those two key words, action and action input. As soon as it finds a match, it knows the model wants to use a tool. This simple parser creates the entire conversation between the AI's brain and its hand.
So our hand-rolled agent is pretty clever, but, it can be a little fragile. It really depends on the model following that text format perfectly. To build something more reliable, especially for complex tasks, we need to bring in some more advanced patterns. And that's where the planner-executor pattern comes in. The best way to think about it is like a manager, the planner, who creates a really clear structured to-do list. Then, a super capable assistant, the executor, just takes that list and works through each task, one by one. By separating the planning from the doing, the whole system becomes way more robust. The key here, the real magic trick, is forcing the model to output structured JSON instead of just plain text. This completely gets rid of the brittleness of trying to parse natural language. Suddenly, the planner's output isn't a suggestion anymore. It's a machine-readable set of instructions that the executor can follow perfectly every single time. Let's talk about another really powerful pattern, RAG. What happens when the agent needs to know something that isn't on the public web or in its training data? Well, Retrieval-Augmented Generation, or RAG, lets us give our agent its own private knowledge base. It finds the right documents first and then uses that information to generate a much more accurate, grounded answer. And you don't need a huge, complicated vector database to get started with this. We can build a tiny RAG system using a couple of classic techniques. First, TF-IDF turns our query and documents into numbers, into vectors. Then, cosine similarity just measures the angle between those vectors to find the documents that are the closest match. We grab those documents, stuff them into the prompt as context, and boom, the LLM gives us a way better, more factually grounded answer. We've come a long way. We've built agents by hand, we've used structured patterns. So for our final section, it's time to bring out the heavy machinery. Let's see how a dedicated framework like LangGraph can help us build truly robust, stateful agents that can handle almost anything. Instead of a simple loop that just goes around and around, LangGraph lets us define our agent's logic as a graph. It's a collection of nodes, which represent states or actions, and edges, which represent the paths between them. It's a much more powerful and flexible way to design complex agent behavior. And this is what that looks like in code. We create a state graph. We add nodes to it, like our main agent node that makes the call to the LLM. And then, this is the really cool part, we add conditional edges. This is the decision-making. A function called shouldContinue looks at the agent's output and decides where to go next. Does it call a tool? Does it loop back to the agent? Or is it done? It's basically like drawing a flowchart for your agent, but you're doing it in code. So, look at how far we've come. We've journeyed all the way from a single, simple script to a self-critiquing loop, to planners, and finally to this robust, stateful graph. Each step on this journey adds another layer of intelligence and reliability. We've shown you the building blocks, so the only question left is, what kind of agent are you going to build next?